This is Mrs. Vara, and I am doing the last example in your 4-1 notes. So these are your 4-1 notes, and it's graphing. Now we're going to graph these using Desmos, and I'm going to try to show you the Desmos on my screen. So the first thing you want to do is to go to Desmos, like I have here, and you want to type in that function. So if you go to the bottom of your Desmos screen here, and there's the keyboard. This is what you can use for other exponents. This would be your x squared, and this would be your bigger exponent. So you want to get the function typed in. Okay, now you're going to have a nice graph of it here, but what you need on your paper is a table of values. So if you click up here on that, it looks like a little gear, and then you click the icon that looks like a table of values, you're going to get the exact 5 points that I want you to include on your paper. So these are your x's and these are your y's. So then you can fill those right in on your paper. So your x's are always going to be 0, -1, -2, +1, +2. And then you're just going to fill in your y values right off your screen. 3, -4, -3, 0, and 1. And then you're going to graph those. Now on this graph, what I'm looking for is all 5 of those points. And I want smooth curves. Should look just like the screen on your computer. And I want arrows at the end. So if any of those things are missing, then you're going to miss points. So I'm going to do 0, -3 first. And then I'm going to do over 1 up 0, over 2 up 1. So there's my points. Over -1 down -4. And over -2 up 3. So you might want to pause the video and graph those a little slower. So those are the points. They look a little random, but when I go back to my screen, I can see the general shape my function is taking, and then I'm going to fill in between those points. So what is happening is it went down, and went all the way up through this point, and then down again, and then arrows. So I want to be able to clearly see the 5 points. Notice I have nice smooth curves, no sharp corners, and arrows. And if you ever want another point, say, well, I'd really like to know what's happening at 3, you can put your cursor on x equals 3, type it in, and it will tell you, oh, at 3 is -12. So if you wanted another coordinate point, you could do 1, 2, 3, and down -12, which would be way down here. So then my graph should really do that. Okay, now let's look at the end behavior. So when I look at this, the right side, right, where the x's are positive over here, my graph is going down. So where the x's are positive, where x is approaching positive infinity, my graph is pointing down, so that would be -infinity. And the left side over here, where the x's are negative, my graph is pointing up. So where the x's are negative, my graph is pointing up. And this also goes with that chart we have in our notes. We have an odd degree with a negative leading coefficient. So odd degree means one side up, one side down. Negative leading coefficients means right side down. Now I want you to do the second one by yourself, and then check that this is your table of values, and your graph should look like this. That's all.